All right, imagine you're a farmer. You've got a field of crops and you're worried about pests, those tiny critters that love snacking on your hard work. The big question, how do I estimate the total number of pests invading my field over the entire crop season? That's where calculus steps in to save the day. Let's break it down. Say you know the pest population at any time during the season can be estimated by a function. Let's call it PT, where T is the time in weeks. Maybe from past observations, you know that at any given week, the pests grow following a pattern like PT equal sign 200 asterisk E circumflex, 0.05T. Here, E is that famous mathematical constant, and 0.05 is the growth rate. But you don't just want to know how many pests are there at the start or the end. You want to estimate the total pest presence, the sum of all the pests week after week over the whole season. How do I do that? Integration. Integration is like adding up tiny slices. If I integrate PT from the start of the season, T equals sign 0, to the end, T equals sign 12 weeks, I'm basically adding up the number of pests for every instant in time, giving me the total pest exposure my crops faced. So the magic math formula looks like this. Total pest exposure equals sign from 0 to 12 of PT dt. Let's plug in that function. Total pest exposure equals sign from 0 to 12 of 200 asterisk E circumflex, 0.05T dt. Now I won't make you sit through all the integration steps, but the answer gives you the total pest pressure over the season. This is way more useful than just counting the pests at one point in time. Here's where it gets cool. If you want to try it yourself, grab a calculator or use websites like Wolfram Alpha. Plug in the function, set your limits, and boom, you've estimated the total pest growth. So next time you're asked, what's the use of calculus in real life? Remember the pests. Integration helps us tackle real-world problems, from farming to medicine to predicting the next viral video trend. Give it a shot and try estimating your own pest problem with integration. And hey, you might just save a crop, or ace your next math test. See you next time.